Hello viewers, in this part 2 we are going to see the formulae based on the area. So the first formula is area of rectangle. It is length into the breadth. So I'm going to just write down the formula here in the copy so that you can keep with me all along. Stay with me. Important formula. Using this formula we will solve the two questions also. So the first is area of rectangle. It is length into breadth, and length is area divided by breadth, and breadth is area divided by length, and perimeter of a rectangle is 2 into length plus breadth. Area of a square is side square, or there is another formula for that is half of the diagonal square. So there are two formulas for area of the square. First is side square. This is the square and this is the side. We can just take the square of this and get the area of a square, or we can just take the square of the diagonal and divide it by 2. Area of 4 walls of a room is 2 into length plus breadth into height. You all know length plus breadth means length 2 into length plus breadth means perimeter, and into height, and we can get the area of the 4 walls in the room. So if you look at the room, it is simply rectangle, and if you add the height it becomes the room. So we will multiply by height to get the area of the room. And now we are moving to the area of triangle. So there are formulas, or you can say formulae, on the area of rectangle. So we are going to see that the first formula is half into base into height, and the second formula is this formula is also known as Heron's formula, under root s into s minus a into s minus b into s minus c, where s is the half of the parameter, that means a plus b plus c by 2, and a, b, c are the length of the sides. Area of an equilateral triangle. Area of an equilateral triangle. The area is under root 3 by 4 into side square. Area of triangle. Half AB sine theta, where AB are the length of any two sides of triangle and theta is the angle between them. Suppose it is the triangle and this is theta, this is A, this is B. Okay, so now we are moving to next thing. The next thing is radius of incircle of an equilateral triangle of side A. So radius of incircle, what do you mean by incircle? Suppose it is the triangle and we are drawing a circle in it that is just touching its inner sides, and then the radius of this inner circle would be A divided by 2 root 3. And now in the next formula we are going to see the radius of the circumcircle. Radius of circumcircle will touch the outer sides, and the formula for that is A divided by under root 3. Radius of in circle of triangle of area triangle and perimeter S. So suppose it is the triangle and it is the incircle, and we need to find the area. In the previous case we found the radius, and the radius was A by 2 root 3, A by root 3. In this case we are going to find the area. So the area is whatever the area of the triangle divided by the perimeter, half of the perimeter. S means if it is A, B and C, then S is A plus B plus C divided by 2. So this way we are going to find out the area of the incircle. And radius of circumcircle of a triangle, there are two formulas. It was the case with equilateral triangle. They both were equilateral triangle. In this case we are going to see a general triangle. Suppose it is this triangle, it is not equilateral triangle, and we are going to see the circumcircle of this triangle. The formula for this is product of sides A into B into C divided by 4 into area of parallelogram. So a parallelogram looks like this, and the area is base into height. Area is base into height. Area of rhombus. A rhombus looks like this. All its sides are equal, and its area looks like this. Product of diagonals. So this is the rhombus, and the product of its diagonal into half is its area. And the area of trapezium. So the area of trapezium is half into sum of parallel sides into distance between them. Suppose it is A, suppose it is B, and the sum of the parallel sides, that is A plus B, and let the distance between them be D into D. So that is the answer for the area of trapezium. Now we are going to see the area of circle. Area of circle is pi r square, where r is the radius, and circumference of a circle, it is 2 pi r, and the length of the arc. Length of an arc is 2 pi r theta divided by 360. Remember, we are multiplying this 2 pi r, that is the circumference, by theta by 360, where theta is the central angle. Area of a sector. Area of a sector, it means half into arc length into r, that means pi r square into theta divided by 360. Area of semicircle. Pi r square divided by 2, half of the area of the circle. Circumference of semicircle. Pi r. Perimeter of a semicircle. Pi r plus 2r. So it is the semicircle, and this whole thing is pi r, and this is 2r, so it is pi r plus 2r. Area of regular polygon of n sides with the length of each sides. So we are going to find the area of polygon of n side with a as the length of each side. Suppose a polygon is given and a is the length of each side, therefore the area is given by a n square 4 tan 180 divided by n. Area of regular hexagon of side a. A hexagon is the closed figure in which 6 sides are there. The area is 3 root 3 divided by 2 and a square. Area of regular pentagon of side a. So a pentagon in which is a closed figure in which 5 sides are there, and each side is of a, and the area is 1.72 a square. The area enclosed between circumcircle and incircle of regular polygon of side a is pi a square by 4. The area enclosed between circumcircle and incircle of a regular polygon of side a is, suppose it is the regular polygon, and it is the circumcircle and it is the inner circle, and the area enclosed between them is pi a square divided by 4. It is the answer. Okay, so we are going to solve the two problems based on the areas. The first question says, find the maximum distance between 2 points on the perimeter of rectangular garden whose length and breadth are. Length is given as 100 meter and breadth is given as 50 meter. Find the maximum distance between 2 points. Okay, so the parameter is 2 into L plus B, as we have seen in the formula, so it is 300 meter, and we have to find the maximum distance between 2 points. So it is 100, it is 100, it is 50, it is 50, and the parameter is 300, and maximum distance between 2 points. So it is the maximum distance, so we need to find the diagonal. Therefore 100 square plus 50 square and under root 10,000 plus it is it will come out to be under root 5 and 50 root 5. 50 root 5 would be the answer if you solve it. So that is the maximum distance. We have used the Pythagoras theorem. It is hypotenuse is equals to base square plus perimeter square. That's what we have used. Okay, so moving to next question. The next question is, one side of rectangular field is 15 meter and one of its diagonal is, okay, the field is given as rectangular and one side is 15 meter and one of its diagonal is 17 meter. Find the area of the field. So we need to find the other side. We can do this by using the Pythagoras theorem, and 17 square minus 15 square, that will be the, let it a, that would be the a square. So 17 square is 289 and 15 square is 255, and we have to take the under root of him and we will get 8 meter as our answer. So it is 8 meters, and now we can find the area, that is simply 15 into 8, that is length into breadth. The area is 120 meter square. So thank you for watching the video.